Sketch the graphs of an exponential and a log function, identifying asymptotes and at least 3 points. Give the points exact coordinates. Do not use a calculator for the x or y coordinates of the points. Alright, so we have y equals 3 to the x plus 2. Now, an exponential, this is a nice way to remember exponential. The first way you start to draw the e is the exponential shape, the lowercase e. This has a horizontal asymptote. The horizontal asymptote is found, it is a y equals. If you cover up the exponential term, you'll just have y equals 2. That is the horizontal asymptote. So we can plug this, put this down on the graph to start off. And I'll label it. We've labeled that one on the left, so it doesn't interfere with the right graph. Now, the points on the graph, if I use 0, I like the 0 if I can get the exponent to be 0. 3 to the 0 is 1, plus 2 is 3. And if I use 1, 3 to the 1 is 3, plus 2 is 5. And let's see, 2 might be too big. Maybe we do negative 1. Negative 1, 3 to the negative 1 is 1/3. 2 plus 1/3, 2 and 1/3. This should be enough for us to graph this. So we have 0 and 3, 1 and 5, negative 1, and 2 and up 1/3. So the point in the middle, I call this the anchor point. This is the point where you get the exponent of 0. In this case, letting x equal 0 does that. So the anchor point will be the boundary between the very fast growth on one side and the going to horizontal on the other side. This is extremely difficult to graph because your graph shouldn't ever go up any. It always continues to decrease towards the horizontal asymptote. So as soon as you feel like it's getting too close and you're going to start wiggling, just end it with an arrow. The horizontal asymptote is labeled so that people know what you meant to do, and this would be perfect 100%. Now, shifting over to the log that we're dealing with. The word log also has some nice lowercase. The horizontal asymptote for an exponential is actually a vertical asymptote for the log, and the L reminds you of that. And then the log shape just kind of hugs the O in that shape. Continues to go up. Logs do not have horizontal asymptotes, so this graph will eventually get up to positive infinity. Just like exponentials do not have vertical asymptotes, this graph will eventually go to the right forever. Okay, so we have a vertical asymptote. Now the vertical asymptote happens when the inside, called the abscissa, is equal to 0. So the asymptote is x equals negative 2. So we can dash that vertical asymptote. Now the points on the graph, if I get the abscissa to equal 1 by putting in a negative 1 for x, and then we have log base 3 of 1, log base 3 of 1 is 0. If I plug in 1, positive 1, now I have log base 3 of 3. Log base 3 of 3 is 1. And if I use, what's the next multiple of 3? 9. So if I use 7, then I get log base 3 of 9, which is 2. So I'm carefully picking the x values so that I end up with log of 1, log of the base, and log of the base squared. And that gives me some nice points to use. So negative 1 comma 0, 1 comma 1, 2, 3, 4, 5, 6, 7 comma 2. And this is the anchor point. It's when you have log of 1. Notice the anchor point for the exponential is when you have exponential of 0, because that equals 1. And the anchor point for log is when you have log of 1, because that equals 0. They're actually the inverse points, essentially. So one side is where it kind of goes off to the right infinity, and the other side is when it approaches the horizontal the asymptote, the vertical one in this case. Same issue. When your graph looks like it's going to start to curve to the right or anything other than continuing closer, just end with an arrow, call that good. On the right side, make sure this does not go horizontal. It continues to rise up. All right, I hope this helps.